So welcome everyone to today's Snapshot Series webinar on AIOps. It's the second webinar on this topic this year. Today I want to focus on topology analysis and give a little outlook as well into impact analysis. And to that end, I have again prepared with my colleagues Jupyter interactive Python notebook. This gives us the possibility to directly interact with StableNet in a nice way using the REST APIs, and in the same time basically take the whole functionality that Python libraries are offering us for doing different things, in this case with the topology analysis. So I have reset my notebook, cleared all the outputs, and I will just now run all cells one after the other, provide my password here. Other than that, it runs automatically, and while it's processing everything down below, I will just explain a little bit what we see here and what we do. So the Python notebook is first loading some libraries and is also using some two extra Python files that we have that have some functionalities that we have encapsulated for you for easier usage, that are not part of this Jupyter notebook, but that come together with it as two separate Python files. And then here we are just providing the credentials of our server with the password being requested, the rest being coded here. And now I'm accessing this server, and I'm actually providing some IDs of weather maps that I will be working with a little bit more in the next steps. And as you can see here, we have encapsulated some of the functionality. For instance, the functionality reading weather maps with the REST API is just a simple method here, get weather map with an ID. This makes it easier to use and to work with. And the first thing I'm doing here is just like getting the weather map called KDL, which is one of the topologies of the topology zoo that I'm taking here as an example. And I'm plotting it as it is. And I also have here some notes directly in my interactive notebook. So for you looking at this notebook later on, we can provide it for you, of course. You have the possibility also to read this yourself and to reflect a little bit more on these topics again. So as it says here, the graph is far too crowded to identify bottlenecks ourselves. So if I was asking you where is a bottleneck in this topology here, it's very hard, I'd say even impossible, to directly see in this large topology where there is a bottleneck, because it's just far too much to see here, too many nodes, too many links. So this is hard. So let's now start with the topology analysis. Using, among others, a powerful Python library called NetworkX. And NetworkX, NetworkX is a Python library that offers a lot of graph metrics that I can calculate, and we have this available here in this notebook. So the first thing I'm doing here is I'm working with the edge betweenness centrality, which is a metric that indicates on how central specific edges in the network are in terms of shortest path routing. So if I'm just showing the example, this is better than 1,000 words. This example is basically highlighting taking all the different nodes in the network and their connection to each other using shortest path routing. The edge betweenness centrality is indicating on how often a certain edge is being used on the different shortest paths between the different links. And now suddenly in the same picture, same layout, you can suddenly see specific links here that are highlighted, that are actually, the highlighting is indicated here, the traffic light, the red color is indicating that this is an edge which has a lot of traffic, a lot of the shortest paths in the network are flowing through this edge, and suddenly this is visible here. Let's do another thing. Let's now go from the edge betweenness centrality to the normal betweenness centrality, which is basically the node betweenness centrality. So now we are not looking at edges, but at nodes, and we are coloring the nodes as well. And you can actually see, as it would also be expected in this case, because I'm showing both here, that the nodes that are related to the links that have a high edge betweenness centrality equally also have a high node betweenness centrality. So these nodes as well are located on a lot of shortest paths. So this is another example of a metric that is indicating for me here that these are sensible components in the network. And now, actually, in the following 2-3 minutes, I will just show a little bit more of different examples. And you can also see in this notebook here where it says "Try it yourself." You have quite a lot of examples mentioned here that you can use from the Network X library. And this all comes directly without we didn't have to reinvent the wheel here. We could just use this Network X library, and this gives us a chance to really provide a lot of possibilities here. So now let's just do this maybe with some examples. By the way, here I have a 3-dimensional visualization. This is also possible if you use the plot 3D as true flag. You can also visualize it in 3D, but I will get to this maybe in a moment. For now, I will just comment this line and rerun it without the 3D. So we just get a 2-dimensional one. And now another metric we are looking here at is the closeness centrality, which is an indicator on how close a node is to the center of the network. So green means that the node is quite central, which is again measured based on the shortest path. So if the node has a lot of other nodes that are close by, it tends to have a green color. And if it has a lot of nodes that are rather far away, it's orange or red. In this case, I'm inverting the coloring because otherwise larger values would mean greener color. If I remove this, if I set this to false, you will just see after replotting the plot that red means center and greens means outside of the center. But as this is probably counterintuitive, we are here just inverting the colors. Now, maybe just to pick 1 or 2 more examples of this list up here. One more thing that is quite interesting is the coreness. The core number. You can find more information if you use the help function. So let's just do this real quick. Help core number. There we go. And I'm just running this. It is telling me the nx.core number, of course, nx.core number. It is telling me that the core number returns the core number for each vertex. A k-core is a maximal subgraph that contains nodes of degree k or more. This is too much to explain in all detail for a 15-minute webinar, but I will just show the result, and it's much better to explain it with the result in this concrete example. So let me just go here and enter it. So the core number in this case is indicating me green values mean that the nodes are better connected to the network. In this case, having at least 2 links. The red nodes are those links that are either leaves, so have only one connection, or will have only one connection if you remove another one. So this is basically a metric indicating another way of resilience. And maybe the last example that I will pick here is the node click number, which is also offering some nice insights. The node click number is actually indicating for me the largest click that these nodes are actually part of. So this means if the nodes are red here in this case, they are just fully connected with one other node, which is like a bidirectional link. And if they are green, they are part of a triangle. I don't have any fully connected, fully meshed squares here, so I would have yet another color. So in this case, you can directly see all the triangles with green color. Maybe just so much about the metrics. As I said before, we are very happy to provide this notebook to those of you who want to have a more detailed look at this. So let's do some more things here. We have integrated in the functionality. We have integrated some plot keywords that you can use. For instance, changing the node sizes of the resulting pictures, the line width, the font sizes. If you show labels, you can work with the node colors as you've seen before. You can switch on and switch off labels. You can also use positioning. So if the graph, this is a layout which is provided by StableNet. So the weather map is layouted in the same way in StableNet already. But if I'm switching this to false, then it will lay out the graph. So there are different options here just to show this. So now let's maybe just follow a little bit that notebook to give a quick overview what more we have here in terms of topology analysis. Now we want to analyze our graph not just in terms of like coloring it in a traffic light, but we want in addition to look at a cumulative distribution function. So you see this one here. So what we basically see here in this graph is the same as above in the topology, but now we basically get a graph of all the different metric values that we have. So green would be the lowest values here. So we can see that the largest part of the graph is green, which resembles to, let's say, here that about 80% of the values are between 0 and 0.05. This is what I can read here in this graph. And then there is a much smaller number of values here in the graph that have much higher numbers. So for instance, we can see that just like 2 or 3 nodes here are in the dark red color. So this can be, if you want to look at it from a more mathematical way to get a better understanding in terms of statistics, you can use such graphs. Now we have here a comparison of 2 different plots showing 2 topologies. These are other weather maps in StableNet. And again, we see some cumulative distribution function of that. Now, yet another thing that we have implemented here is now we want, imagine that you did some analysis and you might think of doing this analysis in a regular way using this Python scripts. So wouldn't it be nice if you actually get this data back into StableNet directly, so that you have this graph here with the visualization, but rather than looking at it only here in this Python notebook, you actually want to look at this graph directly in StableNet. So what we are using here is we are using the capacity metric module that we have introduced with StableNet Release 11, which gives us the possibility to put additional values onto links and nodes in StableNet based on offset values and multiplying values. And with this done, we can actually do the following here. We can calculate a graph with the coloring, and then we can upload this weather map using the REST calls for adding new weather maps. With actually using these color schemes for the betweenness centrality. Those are the color arrays here, betweenness centrality and edge betweenness centrality that I'm using for the colors. And we are actually putting this to StableNet as a weather map. I will just show this weather map 2712 in StableNet, then it's clearer, I guess. So let's quickly jump to StableNet here, and I'm jumping to this 2712 weather map. Here we are. Now you can't see a lot because it's too small, so I'm zooming in a bit, and it's taking a short moment to calculate. And now I have the values here, and if I'm doing a mouse over, I also get in the tooltip, I get my betweenness centrality values in the tooltip, and I get the coloring here, so I can directly use this as well in StableNet. This is quite a large example. The next one here, the 2713, is a smaller one where it's better visible. Here you can directly see the values. So if you want to use this for dashboards in StableNet or for reports, you can directly use it here. The only prerequisite is that you have a script as the examples here in this Python file that actually upload the weather maps, and you need to have the capacity metric module to get that functionality. There are more examples here. So this is the example that is creating the weather map that I just opened here in StableNet. This is the same weather map as the one before, but with custom color ranges. So I'm changing the borders when it should be yellow and red so that I get less yellow and more green, basically to highlight different aspects. And the rest of the notebook, I think I will skip for this webinar because it's just more examples of metrics, also some metrics that we have calculated ourselves to do more complex analysis. So I will not go into this in more detail, but it's basically, again, different displays with labels turned on. And then there is also this 3D functionality, in this case for a larger graph. Which is maybe giving less visibility here for a smaller graph. So you can see certain structures of a graph that are maybe less visible in a two-dimensional view. So this is also included here. And again, this is using Python libraries to offer such 3D graphs. And now as the last part of my webinar, I want to quickly jump again to StableNet and give you a short indication on what's coming up next, what we are currently working on on the final stage with a customer, but what will be then available for all the customers in release 12 and also earlier. If you need it before, you can reach out to us. This is an impact analysis in StableNet. So really quick, please imagine this topology here, and you have these nodes connected as on the picture, and you have a certain gateway node. And now what you want to look at is if certain nodes are put into maintenance. So if you are doing a planned switch off of these nodes, which other nodes would actually be impacted as well and not reach the gateway anymore. And I'm just showing this here real quick. I'm clicking 2 of the nodes, and I'm imagining that these 2 nodes would go into maintenance by running a prepared job. So I'm running a workflow job called Impact Analyzer that we have prepared here. And in this Impact Analyzer, I'm actually I'm just starting it directly. Yes, here we go. And you will see in a short moment that we actually get here, I have switched off 2 devices, device 4 and device 1. So I'm getting here a new weather map as the result of my analysis. And if I'm showing this map, I can actually see that if I'm putting these 2 devices into maintenance, there is a whole set of devices that lose their connectivity to the gateway. I can also use the other layouts here. For instance, the circular layout, I think it makes it more visible and better readable. So in this case, if I'm switching these 2 nodes into maintenance and switching them off, a lot of other devices also need to be put into maintenance because they are impacted. And I think that's where I want to end my webinar for the sake of time. But as I said, there will be another webinar, I guess, in the future specifically on this topic, which is upcoming. And for the topology analysis part that I have shown here with the different analysis and the different layouts, this notebook is available upon request, and you can then easily just change the first cell here to make it work in your specific network and start analyzing your network. If you have any feedback based on the analysis in your network and you want us to add anything to the notebook or get any questions, we are also, of course, very, very happy to take those. Thank you very much.